Okay, so this is activity 3.13, I believe. Let me make sure. 3.13. Yeah, and so what I will do, you should have made a prediction and you should have done this. However, I want to make sure that you guys are understanding it. So I've got the two long bulbs connected here. I've got everything connected. All I have to do to charge it is just simply do that. So that's what I'm going to do is I'm just going to charge it like so. And notice how it slowly goes out. Okay. Now, I don't want to discharge it. Okay. So you make your prediction. And then I'm going to grab another wire here, if I have one, right here. And then I'm just going to attach it like so. And then I'm going to just touch it right there. I just tapped it. Okay. Then it tells me to connect it back together. So I will do that. I'm going to connect these guys back on. And then it tells me to follow just regular discharging. And so then I'm going to discharge it just by connecting these guys like so. Oh, wait a minute. The light bulb didn't light up. That's interesting. So let's do that again. However, I'm going to do it a little bit more dramatic. Instead of doing these, I've got a 9-volt battery here. Okay, a little bit more pop. So I'm going to connect this guy like so. And then I'm just going to touch it like so. And notice how the light slowly goes out. So then I've charged my capacitor. Now I'm going to disconnect these guys again once more. Now I'm going to do the exact same thing here. Now I'm going to tap it, so watch. Oh, you see that? Little spark. Okay, so now let's connect it again. Now we should be able to get some discharging, right? So now I'll connect it like so. And then I'll take these wires and... Wait a minute. What's going on here? Why are these not lighting up? Well, it must be something wrong with the bulbs, right? Well, I can connect it here again and see that it's going to still charge. So there's something that's happening when I take these guys off, because if I discharge them, I can attach those like so, and I can discharge it and the light is still lighting up. However, when I have that charge and I bring just an independent wire here, I basically removed everything, and even if I just do a quick tap, no longer will these guys discharge, which means that the capacitor right there, see, I'll touch it again, no lighting up. That suggests that the capacitor can't pump any more charge. So what's going on here? Well, let's talk about the questions. The questions, question number 2 said, describe your observation. Well, I did it with a higher voltage, and so you could see that there was a literal spark there, right? And also, when you connect these guys, do they discharge? No. So that's an observation. You should say the bulbs do not light on discharging. And so then the question asks, explain what this investigation indicates regarding the resistance of the connecting wire. Well, we've done several experiments suggesting what the resistance of the connecting wire is, but let's just think about this. If we have charged this guy and then we just barely tap it, what's going to happen is that this guy right here has somehow quickly just all of a sudden lost all of its ability to push. And so when I connect these guys here, there's no longer able to discharge because of the very limited resistance. And so when a capacitor is returned to the circuit for discharging, the bulbs do not light. This provides evidence that the capacitor was already discharged. That's what happened when I connected these guys when it was charged and then connected it here. I basically just through that tapping, I discharged it. This occurred even though the connecting wires was in contact for a very brief moment. Thus, the capacitor had discharged instantly through a very, very small resistance wire. And that's why we consider these guys as being very, very small resistances, because it almost discharges almost instantly. Here, with the regular light bulb, when I see a discharge, these guys have pretty high resistance compared to a connecting wire. These connecting wires have very low resistance. Well, what's that mean? Well, the wire, which has very low resistance, very, very low, causes it, just by simply touching them, causes it to no longer discharge. However, when we run it through something that has a higher resistance, like a light bulb, we can still see the discharge, just like that. And so what does it suggest about the resistance of the connecting wire? It says that they have almost zero resistance. That is activity 3.13.